In this video, I'll be showing you how to build a local AI agent in just a few minutes using Python. We'll be using Ollama, LangChain, and something called ChromaDB to act as our vector search database because I'm going to show you how to add retrieval augmented generation into this app. That essentially means we can retrieve relevant information from something like a CSV file or a PDF and bring that into our model. Now, all of this is completely free. You don't need an OpenAI account. You don't need a Claude account or something. You can do this all from your local computer. So let me show you how to set it all up. So I'm just going to show you a quick demo of the finished product and then we'll get into the tutorial. Now you can see on the right hand side of my screen here that I just opened up a CSV file. This CSV file just contains some fake reviews for a random pizza restaurant. So we have title, date, rating, and review. And you can see something like best pizza in town. Here's the date, here's the the rating of the review out of 5. And then you have what the actual review is and there's kind of some information. Now what I'm going to show you is how to build an AI agent here that can actually go and look up relevant reviews from this document to answer questions about the restaurant. I don't know about you guys, but whenever I go to a new place, I always look at the reviews and typically I'm looking for an answer to my particular question. So this can kind of do that for you. So for example, maybe I want to know, how is the quality of the pizza? Okay, well, what it can do is then go to this document, find the relevant reviews, which you can see it kind of pulls into here and analyzes, and then it gives me a conclusion. Overall, without more data or context, it's challenging to give a definitive score on the pizza based solely on the reviews. However, they do suggest a restaurant with potentially room for improvement in presentation and overall consistency. So there you go, right? I could ask something like, are there vegan options? Let's see what that gives us. And you can see here in conclusion, based on the reviews, there appear to be at least one vegan pizza and possibly more vegan options available. Okay, cool. So that's what we're going to build. This isn't going to be super complicated. It'll be pretty fast. So stick around and let me show you how we make it. All right, so we have a few quick setup steps here and then we can dive right into the code. Now, the first thing that we're going to need is obviously some kind of CSV file. Now, you can use anything that you want, and I'll show you how to adjust this code for your own example. But if you want to download the CSV file that I'm using, I'll leave a link to it in the description. And in fact, all of the code will be available from the GitHub. So you can go to the GitHub and you can download this CSV file and just bring it into a new folder in VS Code. So to begin, open up some kind of code editor. I'm using VS Code, create a new folder. You can see I have one called Local AI Agent. Bring in the CSV file, and then I also created this requirements.txt file, which just has the 3 things that we're going to need to install in Python. So let's get started with that, installing our Python dependencies, and then I'll show you the next steps. So what we need to do is open up our terminal. Again, I'm inside of the directory that I want to write code in for this video, and what I'm going to do is create a virtual environment. So to do that, I'm going to type Python -m venv and then venv. If you're on Mac or Linux, you can change this to Python 3. And what this will do is create a new isolated environment that we can install various dependencies into. If you don't know anything about virtual environments and you want to learn more, I'll leave a video on screen. Now that the virtual environment has been created, we need to activate it. To activate it, if you're on Windows, is going to be /, the name of the virtual environment, / and then scripts with a capital S, and then /activate. When you type that, you should see that you get the name of the virtual environment as a prefix before your command line. Now, if you are on Mac or Linux, then the command is going to be /venv, and then this is going to be bin /activate. Okay, so it's different if you're on Windows, it's this one, and if you are on Mac or Linux, it's going to be this one. And again, I'll leave a video on screen that will go through this more in depth. Now that we have the virtual environment activated, what we're going to do is install the various dependencies inside of here. Now, if you have this requirements.txt file, then you can say pip install -r, and then you can do requirements.txt, and this will install all of the requirements into our virtual environment. However, if you don't have the requirements.txt file, you can just type them out. So you can just install LangChain, you can install LangChain -Ollama, and you can install LangChain -Chroma like that. Okay, so we just need to install these dependencies in order to be able to use these in Python. So that's going to take a second installing of those dependencies for us, and then once that's done, I'll be right back. Okay, so those are installed, and the next thing that we're going to need to get is something called Ollama. Now, Ollama allows us to run models locally on our own computer using our own hardware. So that's why we're able to do everything locally here rather than having to use something like an OpenAI API key. So please go to this page, just ollama.com if you don't already have this software, and simply download it. Once you download it, what you should be able to do is just open up some kind of terminal or command prompt and then type the command Ollama. If you have any issues with this, again, I'll put another video on screen that walks through Ollama in depth and will show you how to set this up. But once we have Ollama installed on our computer, what we're going to do is install an Ollama model. Now, Ollama, again, is just this open source software and allows us to pull various models to our own computer and then run them using our own hardware. Now, depending on the type of hardware you have, that will dictate the models you'll be able to run. For example, you probably can't run a 200 gigabyte model if you don't have a graphics card in your computer. So I'm going to show you a few models that should work on most machines if you have a graphics card. If you don't have a graphics card and you just have a CPU, there's some very small models that you can download and use, but obviously the performance won't be as good. So what you can do is you can actually go to the Ollama library. I'll leave this link in the description, and you can see that there's various different models, and it kind of shows you all of the options that they have. Now we're going to pull two models to our computer. We're just going to pull Llama 3.2. So this is kind of a smaller model that we can use that performs pretty well. And then we're going to pull an embedding model, and I'll show you the name of that in 1 second, which we'll use to embed the documents that we add into our vector store. If that means nothing to you, don't worry, just follow along with the next steps. Okay, so we're going to go into our terminal, and again, we're going to make sure that Ollama command works, and then we're going to type Ollama pull, and we're going to start by pulling the model Llama 3.2. Now you can pull any model that you want. You can choose, you can go look at the directory, but I'm going to go with 3.2. Once that's done, okay, you can see it's here because I already had it downloaded. Then we can move on to the next one. Now the next model that we're going to pull is going to be an embedding model. Now this embedding model is going to be MXBAI, and then this is going to be dash embed dash large. There's various other embedding models you can use, but this is the one we'll use for this video. Okay, so we're going to go ahead and hit enter, and then again, download it to our computer. These are not super big, so you should be able to run them on your computer if you have any kind of GPU. All right, so now that we have these models, we're good to start writing some code. So I'm going to go back into VS Code. I'm going to make a file called main.py, and in this file, I'm going to start writing some code. Now you'll notice that I actually get this autocomplete here. This is coming from GitHub Copilot. You know, that really cool assistant that replaces a lot of your manual typing work. They've actually sponsored this video. And speaking of Microsoft's GitHub Copilot, I was fortunate enough to have them sponsor a video a few weeks ago on AI agents, and today's video where I promised to highlight some of the standout ways that developers are using GitHub Copilot that you guys submitted with the Coding with Copilot hashtag. So let's get into it. Check out these examples of how developers are using GitHub Copilot, like Emery, who created an entire Flutter mobile app, Tugdual, who created a Python script to resize and save images, Adrian, who used Copilot as a beginner when he was working in Jupyter to learn better ways to write functions, and Yusuf, who uses it to avoid manually writing tedious documentation. Now personally, I use GitHub Copilot every single time I open up VS Code, and it's insane how well it can predict what I want to do next and save me tons of hours of manual typing. It's literally like it can read my mind. Now I'm sure that you guys have more stories on how you're using GitHub Copilot, so please share them with me using the Coding with Copilot hashtag because I'm excited to check them out. Now with that said, let's get back to the video. All right, so back into the code editor here, let's go ahead and get started. Now we're going to begin by just importing a few things. So we're going to say from LangChain _ Ollama .llms import the Ollama LLM. We're then going to say from LangChain _ core .prompts import the chat prompt template. Okay, now if you're unfamiliar with LangChain, this is a framework that just makes it a lot easier for us to work with LLMs. It's very popular in Python, and it has all of these extensions like the Ollama extension that allows us to directly use our Ollama models. And by the way, what will happen is Ollama should be running in the background on your computer, and it's going to expose a server or like an HTTP REST API that we'll be able to communicate with from our program. So when you pull these models, they are actually running on your own computer, and we can trigger Ollama to utilize these models from code in Python, or we can actually just do it directly from the command line. So everything that I'm showing you here will run 100% locally on your own computer, even though it might not necessarily feel like that. It also means it'll be pretty fast. Okay. So after this, we're going to specify our model. Now I'm going to show you in this code snippet here how to utilize an Ollama model like quite quickly, and then we'll start connecting some more complexity to it with the vector database, and I'll talk about what that means. So I'm going to say model is equal to Ollama. And then inside of here, I need to specify the specific model from Ollama that I want to use. Now, if you're confused on what to put here, you can open up your command prompt. You can type Ollama list like this, and it will show you the models that you have available. So you can see that I have this embedding model, I have Llama 3.2, I have Mistral, I have Llama 2. So any of these models I can use. So what I'm going to do is just copy Llama 3.2. You don't need the latest part of it. You can just do the original name and you can put it right here. Okay, so I'm going to use model Ollama model equal to Llama 3.2. And now I can start utilizing this model and kind of invoking it. So next, what we're going to do is we're going to create a template. And this template is going to be just a string. And inside of this string, we're just going to specify what we want the model to actually do. So we're going to say something like you are an expert in answering questions about a pizza restaurant. Okay. Here are some relevant reviews. And then we're just going to put inside of a variable here, reviews, and say here is the question to answer. Okay. And then we're going to put a question. Perfect. Then what we're going to do is we're going to say our prompt is equal to a chat prompt template. We're going to pass our template, and actually we don't need to pass the model. I don't know why it's doing that. And now we've created a chat prompt template where we'll be able to pass in a reviews variable and a question variable, and then the model can respond to that. Okay. Then we're going to create a chain. So with the chain, we can say prompt, and then we can put a pipe, and then we can put model. Now what this allows us to do is essentially invoke this entire chain that can combine multiple things together to run our LLM. So first, what we'll do is we'll pass variables reviews and question into this prompt, this chat prompt template that we just created. And then that will automatically get passed to our model because we put it inside of this chain, and then it will return to us whatever the answer is. So if we want to test this out really quickly, because this is literally all we need in order to do this, we can say chain.invoke. And then inside of a Python dictionary, we need to specify the two variables that we had inside of this prompt. So we're going to have reviews and then question. Okay, so we'll start with reviews. And for now, we can just make this an empty list. And then we can say question and something like, what is the best pizza place in town? That might not necessarily make sense because this is just about one pizza place, but I just want to show you a quick demo. So we're going to say result is equal to this. And then we're going to go down and we're going to say print result. Okay, so we can just test this out and make sure that it's working, and it should go ahead and invoke our Ollama LLM and give us some kind of response. So let's go here and run this. We can do that by typing Python, the name of our file, which is main.py, or python3 main.py. So I'm going to hit enter, give this a second to run, and we got an error, some kind of formatting issue. So let's see what the problem is. Okay, so silly mistake here, but we actually need to say chat prompt template dot from underscore template. I forgot to specify this method. So of course that was giving us an issue. So let's go back here and fix that quickly, python main.py. And we should see that this works now. Give it a second. And you can see it says based on our customer feedback and ratings, I would highly recommend this, the top rated pizza place. One reviewer mentioned blah, 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 blah. In fact, our own team has sampled their pizza. So it just came up with something random here because I didn't actually give it any reviews. So it's kind of hallucinating the response, but you get the idea, okay? It did actually work. We were able to use Ollama and we got a response from the model, which is really just the point of what we were testing here. Okay, so now what we're going to do is we're just going to put this inside of a while loop. So essentially we can just keep asking it questions, and then we're going to set up the vector search so we can actually get a relevant response. So let's set up a simple loop here. We're just going to say while true. Then we're going to ask a question. So we're going to say question is equal to input. So we can get some input from the user, and we'll say, ask your question. And then we're just going to put a set of parentheses here and say Q to quit. So if they type Q, then we can quit. We're going to say if the question is equal to Q, then we are going to break. Otherwise, we can invoke this chain. So we're going to say result is equal to chain.invoke. Okay, and for the question, we'll just put the question the user asked. So we'll replace this with question, and then we can print the result. Now we also can just have a few kind of formatting variables here. So I'm just going to say print, and I'm just going to print kind of a big line with a few \n characters. And then same thing here. I'm just going to print a few \ns so we can kind of read what's happening. Okay, so we don't need to test this, but this will just allow us to continue to ask questions until we type in Q. Now what I want to do is show you how to set up the vector search. All right, so we're going to create a new file here called vector.py. You can call this anything that you want. And here's where we're going to write the logic for actually embedding our documents and then looking them up, or vectorizing our documents. Now, in case you're unfamiliar with vector search, this essentially is going to be a database. It's going to be hosted locally on our own computer using something called ChromaDB, which we installed earlier. And this is going to allow us to really quickly look up relevant information that we can then pass to our model, and then our model can use that data to give us some more contextually relevant replies. So obviously LLMs are really good at kind of synthesizing text and giving us responses, but usually they don't have the correct data. So in this case, what we're going to do is we're going to take this entire CSV file, we're going to put it inside of this vector-enabled database, and then as soon as we ask a question, we're going to look up the relevant documents in that database. We're going to pass those to the LLM as a list of reviews, and then it will be able to search through those reviews and answer our question. Okay, so that's like the very basics on vector search. Let me show you how we do that. So we're going to say from LangChain _ Ollama, we're going to import the Ollama embeddings. Okay. Now, one thing that we need when we do this vectorization process is an embedding model. This model will be able to take text and convert it into a vector. This is essentially numbers that we can then use to look up data really efficiently. Next, we're going to say from LangChain and then _ Chroma, and we're going to import Chroma like this, which is going to be our vector store. We're then going to say from LangChain _ core.documents, import a document. We're going to create documents and then pass these to our, Chroma database. We're then going to import OS, and we're going to import something that I forgot to install before, which is pandas as PD. Okay, now pandas is a library that we can use to really easily read in our CSV file. So just quickly before I forget, we do need to install this. So same as before, we're going to type pip install pandas in our virtual environment, and then we should install that dependency and be able to use it. I'll also add it to the requirements.txt file, so if you guys were to have downloaded this before, you would already have it. Okay, so pandas is installing. We can just wait for that to run and start writing some more code. So first things first, we're going to load in our CSV file. We're going to use the data in the CSV file for our vector store, so of course we're going to need the data. So we're going to say df, standing for data frame, and this is going to be pd.read _ CSV, and we're going to read in the realistic _ restaurant _ reviews.csv. And obviously, read in whatever the name of your CSV file is. I think that I spelt that correctly, although maybe not. Restaurant, let's see. You know what? We can just do this. Rename, copy, and then paste here to avoid any misspellings. Okay. Anyway, so we have our data frame here. Next, we're going to bring in the embedding model. So we're going to say embeddings is equal to the Ollama embeddings, and then we're going to say model is equal to, and then the name of the model that we installed, which is mxbai-embed-large. Okay. Now after that, we're going to specify the location where we want to store our vector database. So I'm going to say / and then chroma _ LangChain, and then this is going to be _db. You can call this anything that you want, but this is just going to be a folder where we store our database. Okay. Next, after that, we're going to say add _ documents is equal to, and then we're going to say not os.path.exists, and then the database location. Now, what I want to do is I want to check and see if this database already exists. If it does, that means that I've already performed the process of converting the CSV file into vectors and adding it into the database. If it doesn't exist, then it means that I need to do that. Okay, so we don't need to keep doing this every single time. We can just one time vectorize our data, and then once it's vectorized and it's in the database, we don't need to do that again. We can just start using it. So below here, I'm going to say if add documents. So if we do actually need to add them, then we're going to say the following. We're going to say documents is equal to an empty list, and we're going to say IDs is equal to an empty list as well. Then what we're going to do is we're going to iterate through our rows. So we're going to say for I, row in df.iterRows. This is simply going to go row by row through our CSV file and then allow us to access the various entries. Now what we're going to do is we're going to create individual documents. We're going to add them to the documents list, and then we're going to add them to our vector store. Okay. So we're going to say document is equal to document. And inside of this document, we need to pass three things. we need to pass a page content. And this page content is going to be what we will actually be vectorizing and what we'll be looking up. So if you wanted to adjust this for your own example, any of the content that you want to use to actually look up the information in the database, that needs to go in the page content. So what we're going to do is we're going to combine the title of the review with the review itself so that we have a bunch of information to be able to actually query our data. Okay, there's all kinds of different things you can do here, but you want to include the important information that you'll be querying based on in the page content. So we're going to take row at title, and then we're going to say plus a space and then row at review. Okay, then we're going to specify some metadata. Copilot's already doing it for me. So we have metadata and then rating, and that's row rating. And then we're going to have date, and then this is going to be row date. Okay, so the metadata is just additional information that we will grab along with the document, but we won't be querying based on the metadata. Okay, so hopefully that makes sense. Again, just additional data that will be included with the document, but it won't necessarily be used to actually query. And then lastly, we can specify an ID. So we're going to say the ID is the string of I, which is just the index of this value in the row or in the, the CSV file, and just make sure that you convert this to a string. Okay, so I think that should be good for now. After this, what we're going to do is we're going to say IDs.append, and we're going to append string I, and then we're going to say documents.append, and we're going to append our document. Now, the reason why we need to store the IDs is because when we actually create this data in the vector store, for some reason, we need two separate lists. We need a list of documents, and then we need a list of their associated IDs in case for some reason they're different. So I know it seems a bit weird that we have the ID twice, but just follow along because we need that for this process. Okay, so now we've kind of prepared the data in documents, and the next thing we need to do is add this to the vector store. So we need to create the vector store. So we're going to say vector underscore store is equal to Chroma. And then inside of Chroma, we're going to specify the location and the collection name. So we're going to say collection name is equal to restaurant reviews. We're going to say the persistent directory, Copilot is leading me wrong here, is going to be equal to the DB location. Now this just means that we'll store it persistently rather than just storing it in memory. You don't need to do this, but I recommend that you do store this permanently so that you don't need to keep regenerating this Chroma database. And then lastly, we need to pass the embedding function, which will be equal to our embeddings from Ollama. Okay, so we're using all of this stuff locally. We have the ChromaDB locally, we have the local embeddings model, and now we have the vector store. Next, I'm going to do a quick if statement, and I'm going to say if add documents, then we're going to say vector store.add documents, and then this is going to be documents is equal to documents, and IDs is equal to IDs. Okay, so this is how you add this. You just say vector store.add documents. You specify the documents that you want to add, which we've already prepared here, and then you specify the corresponding IDs. And we're only doing that if this did not already exist, because if it did already exist, then we don't need to add the documents, right? And we wouldn't have already prepared this data. Hopefully that makes sense, but that essentially will create the vector store for us and automatically add the data. Last thing we're going to do is we're going to make this vector store be usable by our LLM. So I'm going to show you how to do that. We're going to say retriever, okay, is equal to the vector store dot as underscore retriever. Okay. Now inside of here, there's a few parameters that we can pass. For example, we can specify the number of documents that we wanted to look up. So I'm going to say search keyword arguments is equal to K and then 5. Now, when I do this, what's going to happen is it's going to look up 5 relevant reviews and then pass those 5 reviews to the LLM. Now, if we wanted 10 reviews, we would make this 10. If we wanted 1 review, we would make this 1. You can specify as many or as few as you want, obviously minimum of 1, but I'm going to go with 5. Okay. So now we have the retriever, and what this retriever will allow us to do is look up documents. Then we can pass those documents into the prompt for our LLM. So quickly recapping, we import all of the relevant data, we bring in the CSV file, we define the embeddings model from Ollama, we check if this location already exists. If it doesn't, then we're going to prepare all of our data by converting it into documents. We're going to initialize the vector store if for some reason this directory already exists, then there's no need to add the data. But if it doesn't exist, then we're going to add this data into the vector store by adding all of our documents. This will automatically embed all of the documents for us and add it to the vector store. And then we can create this retriever from the vector store, which will allow us to grab relevant documents. So the last step is to simply use this retriever from our main.py file. So we're going to go into main.py. We're going to say from vector import retriever, because we're just going to import it from the other file. And now, before we actually invoke this chain, we can use the retriever to grab the relevant reviews, and then we can pass the reviews as a parameter to our prompt. Okay, so in order to do that, we're just going to say the reviews is equal to the retriever, and then this is going to be .invoke. We're just going to invoke this with our question, and then we can simply pass the reviews that are returned here to our chain. So all that we do here is we just say retriever.invoke. We pass the question, or like the search string that we want to use to look up the relevant reviews. What will happen is the retriever is automatically going to embed that question. It's going to go into the vector store. It's going to look up all of the relevant reviews using a similarity search algorithm. It's going to grab the top 5 reviews, and then it's going to pass this to our chain, and then we can print out the result, and hopefully we get something meaningful based on those reviews. So let's give this a run now and pray that it works with Python and then main.py. Give this a second to run. You can see that it creates this Chroma LangChain DB directory. It will take a second because it does need to embed all of our documents. And now we can ask a question. So I'm going to say, how are the, vegan options? If I can spell anything correctly, which apparently I cannot. Okay, so let's see what we get here. And you can see that it pulls up a few different reviews here, and it says, based on the reviews provided, it appears the vegan options of the pizza restaurant are a mixed bag. On the positive side, some reviewers have raved about the vegan pizzas, saying they're hidden gems, okay? And it even tells us what document it got this from. However, not all reviews are glowing. One reviewer had a vastly different experience with the vegan cheese option, calling it tasteless. And then it says, overall, it seems that the vegan options are hit or miss, but there's definitely potential. And then it gave us a overall rating, 3 out of 5, based on the 2 positive reviews out of the 4 total. Okay, cool. We can also ask it something like, how is the ambiance or something. I don't know if I spelled that correctly, but let's see what it says. It said, overall, I would say the ambiance of the pizza restaurant has an all style, no substance feel. And apparently they don't like the pizza restaurant based on these reviews. But you guys get the idea. It is insanely fast. It uses the vector store database. Everything runs completely locally. And when we're ready to quit, we can hit Q and we can exit out. This was a simple example that was just meant to demonstrate how you can run LLMs locally on your own computer using your own hardware. Obviously, you can adjust the CSV file and you can make this any type of data that you want. It also doesn't need to be CSV data. You can just convert anything that you want into documents like I demonstrated here. And if you want the code from this video, it will be available from the link in the description. If you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.